Let's see. Okay, I believe that we are live. Awesome. All right. Hey, everybody. We have ourselves here a MacBook Pro that's not turning on. It's an A1707, which is a 15-inch 2016 to 2017 MacBook Pro. This one is in here because it just doesn't power on at all. So we went ahead, one of the first things we always do when we are testing out a MacBook Pro, a USB-C model that's not turning on, is we're going to use a handy-dandy USB-C ammeter and check to see if the amperage draw or voltage consumption on all the USB ports are the same. If there's any variance at all in any of the ports, that's probably where our issue lies, because behind every USB-C port is a Texas Instruments CD32 chip. This one is a 2016-2017 model, so it's going to have a CD3215. So let's go ahead and take a look with our overhead camera to see exactly what amperage draw we're getting. Now, one of my technicians have already done this, so they were able to confirm that one of the ports is acting different than the rest of the ports. I personally haven't checked it myself, so I'm just going to confirm the issue before we move any further. So here, we're getting 20 volts at 1.1 amp. So that seems normal. I think from what she was telling me is that we're getting one that is pulling 5 volts while the rest is pulling 20. And let's see, I can't get a good connection on this one. Okay, so we have 5 volts on this side, 0 amps, and let's see if it updates. Nothing on that side, so I'm going to go ahead and flip over the USB-C cable just to check and see if maybe the other side of the USB-C port isn't working, because there is a current sense circuit, and if it's drawing too much current, it just prevents the entire chip from turning on. And we were only getting about 5 volts on that one. So let's go ahead and check out the other USB ports. I believe that USB port's the one that's bad, or something around that USB port is bad. Sorry, I'm listening to some conversations going on at the lobby, and at the same time I'm working on this. It's just me and one of my employees today. Okay, so this one is pulling 20 volts at 1.1 amps, so that seems normal. And this one here is also pulling 20 volts, 1.1. So something is going on specifically on the top side of this USB port. So let's go ahead and pull up our board view software and check and see exactly where that CD3215 is located on this specific MacBook. So we go ahead and we look, this is the orientation that we had our MacBook. It's going to be the top port up here. And I'm just going to click on one of these. This specific pin, this one is PP20V USB-C XB. So this specifically goes to the CD32 that Apple has named XB. And that is going to be, let's see, that's just the power for it, but I don't actually see it. So let's click on a different line here. That's ground. Here we are. USB-C XB CC1. That's going to be the current sensing circuit I was telling you about. And it looks like it's this USB-C chip, the U3200, CD3215. So for some reason, this chip in particular is not working like it should. Now, is it because there's something going on with the current sensing? To figure that out, what we're going to do is we're going to get a multimeter, and we're going to measure the resistance to ground specifically on that pin, the one that says CC for current, to see if we have a short or a partial short. So let's go ahead and flip over. Now, I am using my standard Fluke 115 multimeter today, so I don't have the one that actually pops up on the camera, usually in the corner. So I'll just read off the readings to you. Let's go ahead and put our multimeter into resistance mode and go underneath the microscope camera. And sorry, juggling conversations in my head while also trying to do this. I forgot exactly which pin that was. So if we look, that's going to be the second pin from the big one, or pin 3. And what I meant by the big one is you can see this guy right here, this is going to be the first pin. So the second pin, or third pin, the second pin down from the big pin, but the third pin in total, we are getting a measure on my multimeter of 10 mega ohms. Mega is going to be million. So there is not a short there on that specific CD32. This chip honestly may have just gone bad. Now I can give it a visual inspection to see if it's got a hole in it, and it looks fine to me. I'll let you guys take a look at it too. So here it looks fine. Is there not one up there?
It's not a 96.
Ah, gotcha. Okay. Okay, and so from here, this chip looks perfectly fine. Okay, sorry, it is really hard to listen to conversations going on up front while also running a live stream at the same time. Okay, so let's look and check the other current sense just to make sure there's not a short on there. And so that's going to be the third pin down from the big pin up here, so actually pin 4 essentially. And let's go back over to our microscope camera to take a look at that as well. And that is this pin. With the multimeter, we are still in 10 mega ohms. So the fact that all the other USB-C are getting 20 volts with roughly 1 amp kind of leads me to believe that this specific CD3215 has failed. So there are other diagnostic steps we could test, for instance, using a thermal imager and see if there's anything that gets hot. You always want to check and see if PP bus is shorted to ground. I've already gone ahead and done that. And it's not shorted to ground, so we're fine there. So I think at this point, we should probably just go ahead and simply replace that CD3215. And let me show you my process for how I do that. Fortunately, this one is not underfilled, so there's nothing to have to worry about scraping off. No resin. Making sure the camera is balanced, so what you guys see is what I see. Looks good here. And then now, what I will do is I'm going to take a scalpel, and I'm going to look for a part of the board that doesn't have any vias or lines, line traces coming out of it. So like right here in this corner, you can see this giant area. This is typically going to be a ground connection. And what I want to do is mark this part of the board so I know exactly where to line up this square chip when I'm heating the replacement CD32 into place. So what I'll do is I'm going to take the back end of a scalpel, so I don't dig too hard into the board, and I'm going to brush it up against the chip to make a little line like that. The reason you don't want to do it to a trace is you might accidentally push too hard and cut through the trace. So we're going to do the same thing right here in this corner. We're going to have like a little X. And this is just going to help out with alignment. Now, up here, I also have a bigger trace that I'm not too concerned about severing. So I'm going to do the same thing. That way I can align the replacement CD32. So I have right here a corner piece, kind of like an X marks the spot situation, and then up here another marking as well. I wouldn't want to put a mark right here because that's a very thin trace that's easy to cut through. If you wanted to, you probably could even, this bigger surface area, you probably could mark that as well. All right, so now we're pretty much ready to go. We do have a little bit of plastic right here, so I'm going to try my best to not melt this. And I'm also going to have to swap out my rework station tip because I was working on an iPod Classic last. So you want to make sure that you're using, I have two different tips. One's for an iPhone or smaller boards. The other one's for a MacBook that has a little bit larger of a diameter. So you want to make sure that the nozzle tip that you're using is roughly the same size. It could be a little bit under than the chip that you're trying to replace. It just makes things that much easier when lifting up. So you can see right here that this tip is actually almost the exact same size of that CD32 versus the tip that I did have is a little bit smaller. You could get away with it, but this is the larger tip's gonna heat up the general area better, more evenly, so that this chip is gonna come up. Now let's go ahead and turn on our rework station, and I'm going to start with some lower temperature. Let's start with 250 here for a second. And the reason I want to start with that is I want to heat up the general area of the board. So instead of just hitting the board with a whole bunch of heat at once, to where we have cold spots, I'm going to warm up the board so as we're heating it with the proper temperature for melting the solder, we won't be causing any type of thermal stress. And this can also be solved with using a board heater, a preheater. But for this specific chip application, a board heater isn't necessary. Very good idea. In China, they make it so, without pushing the scalpel. So what are some things that end up killing the CD3215s? Sorry. It's usually an aftermarket charger, a bad cable or a corroded cable, or the connections themselves on the MacBook have been oxidized or bridged and sending a voltage line to a data line or a voltage line to ground. Typically just improper adapters. Now, I have also seen where these things just randomly die. And that's nothing unusual. But there's usually a culprit, and whether it's the device is getting too much power drawn, let's say like you have an adapter that has like a 10 USB output, since these don't have standard USB-A, that might be sending too much current through the CD32 and can kill it. Alright, so I think our board is at a good temperature right now. So now I can go ahead and apply a little bit of flux. I'm also just turning up my temperature so that I can get ready to remove it. So we need some flux so we can melt the solder underneath this CD32 easier and prevent it from oxidizing. And now I'm raising my temperature. Let's go to 450. We were at 250 before. And we also need our not thermals, I'm sorry. We also need our fume extractor turned on to absorb all the fumes from the flux and the solder melting. And now I'm going to go around the CD32 in a circle. That way I'm not just putting heat in one specific part of the chip, I'm evenly heating up the entire area of this board. Let's see. Hands are a little shaky today, but we got it. So there's the CD32 removed. And now we need to wick up the existing solder balls. So for that, let's grab some wick. I personally use Goot wick. It seems to be tried and true. A lot of technicians use this. I haven't looked at any other wick, but the Goot wick, 1.5 millimeter, seems to be the best wick that I've worked with. So there's two different ways to wick up. We can either wick up by using our soldering iron and kind of wicking all this up, or we can use our rework station to kind of wick up this solder, so without actually using an iron. Because we are so close to the plastic fan right there, I'm going to use a soldering iron. I'm trying to really limit as much airflow as possible in this area just so I don't end up melting any of the plastic. If we melt the plastic, it's not the worst thing in the world. We do have replacement or donor boards that we can take the jaw connector from, but it's better to just not damage it in the first place. Okay, we're almost done. Hands are really shaky today. All right. Now let's go ahead and give that a good cleaning. Flux starts to caramelize when it's heated up. It gets really tacky. And we want to clean it up so we can put some new flux down. So I'm going to put a little bit of 99% isopropyl alcohol in a Q-tip. That's really all that we need. That's enough. You need a coffee to balance the shaking. Admittedly, just because I don't do board streams as much, I would say I'm probably just a little bit nervous. But it's alright. After about 10 minutes or so, I'll feel comfortable back in my skin again. Okay, so now let's heat up the area once more. I'm just going around evenly heating up the general area of this board so that we can lay down a thin layer of flux. Don't want to put too much, because I don't want a river of flux to carry away the replacement CD32. I'm going to heat it up some more because, as mentioned, flux gets tacky once it's heated up, so I want this to almost become like an adhesive. So now that we have new flux on there, make sure that we clean up any debris that got left behind. Now comes the replacement chip. Now, if you're looking for replacement CD32s, there's all sorts of different places that you can purchase them from. I want to say store.rossmangroup.com. You can purchase them there, as well as iPad Rehab. I might be speaking out of turn. For the sake of convenience, I ended up just purchasing these directly from Mobile Centrics. There's two different types of CD3215s. There's the CD3215 COO, and then there's a CD3215B, something with a B. I don't remember off the top of my head. I specifically have here a CD3215 COO because that's exactly what was already on here in the first place. Don't want to mix and match CD32s. I want to make sure that I replace it with the right one. Let's go back to our microscope. So one thing you probably, or I forgot to mention, was to keep note of the orientation of the dot. The dot is going to be pointing towards pin 1. So we can see in this orientation, it's going to be the top left. Now let's say you forget that. You can also see right here in the shape, cut out right here in the CD3215, this is going to be pointing in the direction of pin 1. So let me go ahead and open up my packaging here. And remember, orientation is very important. We can't just put a chip back down in a random position. We got to make sure it goes back in the same position it came from. Now, if you remember, I went ahead and marked exactly where to align this. So I'm going to do just that. I'm going to use 2 tweezers and try to put this part of the CD32 in that corner that I marked, and also have it lined up with the marking I have at the top left. So we have an alignment right here. We can see the X marks the spots for that corner of the CD3215, and then up there in the top left we have it lined up. So now we're going to heat this up until we see the chip just kind of dance into place. So before we add more flux, let's go ahead and start heating up the CD32 till we see it move a little bit. That way we know some of the pins are soldering. I also am going to lower my output. I have it maxed out on 120 for this quick 861DW. I'm going to drop it down to 60. Don't want to accidentally blow away the chip. So now, to heat this back up, same thing as we did before. We're going to go around in a circle. I'm probably about 2 inches away from the board, a little higher up than I was earlier. And as this begins to melt, I'm going to get closer to the chip. Okay, so let's start approaching from the corner. I'm going to start from the top left corner because the bottom left corner is where the plastic jaw connector is for our fan. And now, let's take, while heating this up, I'm going to take some flux and put it on the side of the chip so it goes underneath until we start to see it bubble. Every time it's bubbling, that's usually a sign that one of the solder balls is starting to liquefy. Okay, so now I'm getting closer to the CD3215. And here in a second, we should see it move, unless it's so perfectly aligned it won't move at all. Now this is a little tricky, but if you have an available hand, you can go ahead and start turning up your output. So I'm going to go ahead and start increasing it. There we are, the chip's starting to move. And it just completely slid over. Now we could do the wiggle test to make sure it's properly in place. And how we do that is as it's heated up, you just barely poke it, and it wiggled. So we're good. Barely melted our plastic fan connector. Should be able to work with that. So our CD3215 has been soldered back into place. It's perfectly lined up as we look into the corners. X marks the spot right here in the bottom left corner. Top left corner has got a good marking. And now we need to wait for this to cool down. One of the easiest ways to have this cool down if you're using a fume extractor is to simply use your fume extractor. As some old Rossmann videos used to say, this is the super cooling technique. So we take the logic board here and just put it up in front of the fume extractor so it's sucking in air, sucking in cool air to pass it by. So here's the old chip, just so we don't get it confused. I'm going to set it over here on my throwaway cloth. Go ahead and get some of our wick. We don't need this anymore. I think this is actually wick from other repairs. And the board is at a better temperature, at a nice working temperature. Before I clean this up, I want to see if that actually fixed the 20 volt issue. Do you need me to grab one of those? Alrighty. Alright, I'm almost done. Bless my employee's heart, she is juggling 2 phone calls and the front. So hopefully we are done here. So it was this top one, this top USB port. So we're going to plug in our USB-C ammeter. And before we were getting 5 volts. Now we are getting 20 volts, 1.3 amps, just to make sure that lines up with the other one at the bottom. Volts, 1.3 amps. And that should be it. However, I'm going to at least hook it up into our clamshell to make sure it turns on. I'm going to have to pause this for a second. All right, and I'm back. Okay, so I believe that we fixed this. Before I put this back into the top case, I'm going to go ahead, clean up the flux we have here from our CD32. And for that, we don't need to do a full ultrasonic cleaning. Truthfully, in this case, we just have to use a Q-tip with some alcohol and acetone. And I think my employee has that. She does. Perfect. So we are good there. No need to make to interrupt the stream again. I appreciate everyone's patience. And we have just a little bit of flux down here. Awesome. Let's go ahead and put this back into a top case and see if our board boots up now. And I already borrowed this USB-C port, so I'm going to need to screw that back in. And this application is the same when it comes to the CD3217s. There's a little bit more complexity with those since there is some firmware pairing on some of the CD3215s, especially the ones with the four, did I say 15s? 17s. CD3217s, as there is some firmware pairing on the 4-port USB-C models, like the A2141, which is a 2019 16-inch MacBook Pro. You can't just replace the CD3217s with any CD3217. It has to be specifically one that was either pulled off of a A2141 MacBook Pro or an A2251, I believe. I might be speaking wrong, but that's information that doesn't necessarily apply here. CD3215s for T1 computers, not T2, but T1, are not firmware programmed or programmed through firmware. They're not locked to a specific orientation. They're, fortunately in this case, just a USB-C charging chip. I'm not going to worry about putting any screws yet in this logic board, as I mostly just want to see an Apple logo, potentially even a boot up or a login screen. But in this instance, I'm not sure what killed it. Her USB-C port, the client's USB-C port in this instant looked fine, so something was plugged into this, either a bad adapter or a bad charger, could be a bad charge cable. Any of those could prevent this device from booting up. Now I need our battery screw, which I don't see. Let me see where that is located. I may have to find. Hello, Tim. It's good to see you again. Hope you're doing well. I saw on your had a modded Game Boy. Looked really neat. Okay, so it appears that the battery screw has been misplaced. So I'm going to have to replace this one for the client. So bear with me all for a moment while I Okay, what we're going to end up doing is just replacing this battery screw with one from a donor computer that we have here. So I will be pulling that out of one of our refurb computers that we have at the moment. But yeah, optimized logic repair. If you guys are fascinated into live streams as well, or repairs, and just all sorts of other cool repairs. Definitely check him out. He's both on YouTube and Instagram. Most recently, one of the projects he posted was of a modded Game Boy. Thought that one was really cool. Right, so we got our screw out of our refurb. All right. And let's plug in our USB-C ammeter and see if we get any life at all on the MacBook, just to make sure there's no other issues. All right, we have vibration on our trackpad, so the trackpad is getting power. And still nothing yet on the display, so the battery could also just be really dead. We got fan spin. But still nothing on the display. So I'm just going to check and see if our display connection is tightened down all the way.
Would you agree this is a contender for replacement, not repair?
Yeah, that one is pretty bad. Yeah, I wouldn't focus on repairing that one. Okay, so before we unplug our screen, we want to make sure that our battery screw is unplugged. Okay. So connections have been reestablished. Let's go ahead and plug in our USB. All right, we're getting 20 volts. Fans are starting to spin. Trackpad is starting to vibrate. But I don't hear a chime on the computer. So there could still be an underlying issue with this one. Let's see if it responds to an SMC reset, and it's a little tricky to do upside down. Okay, we have an Apple logo. I believe this one is just really dead. And let's see. Perfect. So we are at the login screen. So this is a successful repair. The battery was just really, really dead then. So yeah, in this instance, the troubleshooting we went through is that out of all the USB-C ports, one of them was only pulling 5 volts. It wasn't pulling the standard 20 volts that it's supposed to. I went ahead and just measured to make sure that PP bus wasn't shorted. It wasn't. So that was good. And then I also checked the current circuit, the current sensor circuit, to make sure there wasn't a partial short there preventing this chip from turning on. So at that point, it kind of seemed like the USB chip, the Texas Instrument chip, the CD3215, had in fact failed. So went ahead, we've replaced it, and it looks like we've restored the life back onto this MacBook. So we're going to go ahead and put it back all together, run through a quality control test, and it looks like it's good. But that is the process of how you replace one of these USB-C chips. Sometimes they're going to be underfilled, which means there's a little bit of resin inside or underneath the chip itself. Fortunately, that wasn't the case here. So I appreciate you all for watching, and I will try to keep these streams going. I hope you guys keep watching, and I'll see you in the next one. Bye.